In this lesson, we are going to be simplifying some complex rational expressions. You can see from my first problem here that I have a fraction within another fraction. So here's my other divisor bar. So when I'm looking at this, we're going to kind of look back, and there's longer ways you could do this problem, but we're going to try to do it in the simplest way, and this is actually what you're going to use when you take calculus. So if you take calculus. So we're going to look at simplifying this similar to how we would standard form when we were doing linear expressions or linear equations. So I want you to think back to standard form when you had 1/2 x plus 3y equals 3/4. So think back to a problem like this. And if you remember standard form, x, y equals that number, one of the rules of standard form is that you cannot have fractions or decimals as the coefficients or constants. And so when you look at a problem like this, we would say, oh, well, let's multiply this whole equation by a certain number, and that will get rid of all of our denominators, and then we will have just integers. When we look at this one, the common denominator between 2 and 4 is 4. So we multiply this equation by 4, and we get 2x plus 12y equals 3. So by doing that, we eliminated those denominators, and we had our answer in standard form here. So with that in mind, remember you did that, you've done that even this year, that's a concept you've done quite a bit. With that in mind, we're going to do the same thing with this problem. So you can see that we have two denominators we're working with here within the same problem. Technically, this whole thing's a denominator, but I want you to look at just the denominators in your fractions you can see here. So when I'm looking at these, I can see that my two denominators I would like to get rid of, meaning I don't want them in the problem because it makes it too complex, is e squared and e. So between those two different terms, what's the common denominator? The common denominator is e squared. So I'm going to multiply my numerator and my denominator by e squared. So think of it as taking e squared over e squared. In other words, we're multiplying by 1, because e squared over e squared is 1. But what that's going to do is as I distribute here, so I'm going to take and distribute that e squared here, and to this fraction right here. So e squared times f is e squared f. E squared times 2 over e, if I want to do that on the side here just to show you, 2 over e times e squared over 1. I would cancel these e's, and I'd have just 2e, so plus 2e. I have just simplified this whole area to that. Now in the denominator, so I still have my red divisor bar there, the one that's right here. Now in the denominator, I'm going to distribute this e squared to f squared. So I have e squared, f squared, and I'm writing them in alphabetical order on purpose. And then when I come and multiply the e squared times the 1 over e squared, the e squareds cancel. So I just have minus 1. So take a look at how we distribute that. It looks really messy right now. But hopefully you can see that I distributed an e squared to every term in this problem, top and bottom. Every single thing got multiplied by e squared, which is legal mathematically because I did it to everything. So when you see my original problem, let's just get rid of all this junk. My original problem, and what I've just come up with, these are equivalent fractions. So when you look at that, I think that the one in purple looks a lot simplified, doesn't it? So from here, now I'm down to what we can think of as several fractions, right? These were several fractions. I'm down to just one fraction, e squared f plus 2e over e squared f squared minus 1. So from here, I'm going to use my reducing that I've just been learning this chapter. So I would say in the numerator, I think I have a GCF, which is e. So I have ef plus 2. And then in my denominator, this looks like a difference of 2 squares, doesn't it? So I'm thinking maybe it's ef plus 1, ef minus 1. We haven't really done a lot of those, so maybe we should check that. It would be e squared f squared minus ef plus ef minus 1. See, difference of 2 squares. It does work. So that's what I get when I factor this. As you can tell, nothing cancels in red, right? I can't cancel anything that's up there. So my original answer in purple would be the correct answer. E squared f plus 2e over e squared f squared minus 1. There's one way to write that answer. Or I could write it as I have it reduced. That's another good answer. Both of these are acceptable answers. If you gave these to me on a test, I would give you full credit. Excel math, if I'm remembering right, likes to write these answers like this, and maybe even a combination sometimes. So take the numerator for my top answer, or my second answer, excuse me, and the denominator for my bottom answer. Technically, that's a right answer, isn't it? When I distribute that e, I get back to this numerator. So any of these answers is acceptable. You just have to find the one Excel math is using. I believe it's the blue one I starred, but this other one in full blue could work too. Okay, so let's try another one of those because that's a little bit maybe complicated right away to help you understand. Number 2 is a similar problem. We have a common denominator that we need to look at. So my denominators right now are the x squared and the x cubed. So between those two, my common denominator is x cubed. So x cubed is being multiplied by everything. So I'm going to distribute that x cubed to this x. I would get x to the 4th. I'm going to distribute this x cubed here. So what I would end up having, I'm just going to show this on the side, is 1 over x squared times x cubed over 1. So then these x's reduce, and I'm left with just an x. That's all I have. So I have minus x. In the denominator, I'm distributing this x cubed here. X cubed times x is x to the 4th. And then when I distribute it here to the 1 over x cubed, those cancel. So I have minus 1. Again, when you look at what I started with to what I got here, I very much simplified this equation by multiplying by the common denominator. So from here, when you're down to one fraction, you're going to try to see what you can do to factor. So in my numerator, I notice that I have a GCF. I can factor an x out. One of the biggest mistakes students make is when they're dividing this by x, they just leave it blank. X divided by x is not nothing. X divided by x is 1. Because we cancel it a lot, we think, oh, they cancel out. Remember, when you're canceling, we call it canceling, but really you're dividing it by itself. It divides into 1, and 1 times anything is the anything. So that's why it seems like it disappears. If there's nothing left, that 1 is there. You have to represent that 1. So I'm here. In the denominator, I don't see that I can take out a GCF, but I do think that this right here looks like a difference of 2 squares. So I can write that as x squared plus 1, x squared minus 1. So now I look and say, okay, is there anything else I can do to factor the numerator denominator? Obviously, I'm not going to do anything with that first x in the numerator, but x cubed minus 1. X cubed minus 1 is a difference of cubes. I know it's everybody's favorite problem. So the difference of cubes formula, if you remember from your notes, is this. So my a is x in this case, and my b is the cube root of 1, which is 1. So in my numerator, I'm going to now keep the x that's there, and I'm going to apply the formula with a being x and b being 1 to the difference of cubes formula. So it would be a minus b, a squared, plus a times b, plus b squared. And that's fully simplified. In my denominator, this first binomial cannot be factored anymore. It's a binomial, I look at it. The only binomial that we can factor, that we know of at least, is with a positive, is if it's a sum of cubes. And those are not perfect cubes, at least x squared isn't. So that's done. So it's going to be x squared plus 1. This, however, is a difference of squares. So I need to go one more step and say x plus 1, x minus 1. So now when I'm looking at what cancels, I see that I could do this x minus 1 divided by x minus 1 is 1. And that's it. So when and remember, some of you might be trying to factor that. If you remember from our last chapter, when we try to factor the difference of cubes formula, that's an imaginary solution. So those never factor. You can try, it just won't work. So here is my final answer. Again, these can be written in any order. So if they would put the x plus 1 before the x squared plus 1, don't be freaked out by that. That's appropriate. But you have to be able to recognize that. So there's number 2. Number 3, this one is a little bit different, where we have this random plus 3 on the outside. So what I'm going to do right away is I'm going to kind of ignore that and leave it to the side. So here's my final answer, 3 plus. And I'm going to take care of this fraction right here first. The only thing I see as a fraction in the denominator I want to get rid of is this 3 plus g. So I'm going to multiply everything times 3 plus g. So to do that, I'm going to distribute 3 plus g to this g, meaning I'm just going to write it out right now. You could distribute on the go, and I'm going to show you my work a little better. And then in the denominator, I have that going to the 3. So it'd be 3 times 3 plus g, and then this plus sign. And then this 3 plus g and this 3 plus g cancel, so it's just plus 3. So if I distribute my g right now, I would have 3g plus g squared divided by, and I'm going to distribute that, that's going to be 9 plus 3g. And then if I go ahead and add my like terms, I have 3g plus 12. If it bothers you in the numerator, you could write g squared plus 3g. That's fine. So now what I have is this is simplified. So I have over here my 3 plus. So it's 3 over 1 plus 3g plus g squared over 3g plus 12. So now I'm going to multiply, or I could just find a common denominator if I wanted to, right? We can just add these fractions if you want to do it that way. So I'm going to say my common denominator between these two fractions is 3g plus 12. Does that make sense? So what do I have to do? Just as going back to our adding, if I take these times 3g plus 12, this denominator changed, so I need to take this 3 that's originally there times 3g plus 12. This denominator did not change, so my numerator won't change, so I'm just going to bring this plus sign over, 3g plus g squared. As I distribute, I'm going to distribute this 3. I would have 9g plus 36, and then I'll copy the rest the same, over 3g plus 12. Next, I'm going to combine like terms, so I have g squared plus 12g plus 36 divided by 3g plus 12. I try to factor, right? So when I try to factor this, I would factor my numerator, factors of 36, and add together make 12. And then in my denominator, I don't see a square, so I'm not thinking factor. Remember, we always look for a GCF first, so I can do this. Which, when I look at this, nothing cancels. So whichever answer I would choose, this one could be on Excel Math or this one. They are the same answer. So I could look at either one to get the correct answer. Also, that second answer in green, we often will write that as, when we have the same thing twice, g plus 6 quantity squared. Remember doing that? Okay. So now, I would like you guys to try number 4. So go to number 4, pause the video, for real, like actually pause it so you try the problem. And I'm going to do 4 pretty quick up here, so as soon as you're unpause it, you can check your work. That's one answer. Oh, excuse the bells. And then the other answer, I think this is, I can't remember how Excel Math leaves it actually, because I'm talking about this. So now you can try that answer, or you can say it's this one. We might have left it like this. All of these are equivalent fractions, all 3. So 1, 2, 3 options. Again, I think it could be this one or this one, Excel Math does. Doesn't matter. You should be able to recognize all of them. So hopefully that makes sense. Tomorrow we have one more we're going to do in class. And if you have any questions, make sure you come talk to me tomorrow.